Greetings to everyone at this assembly. My name is Mark Post, and I'm here to talk to you about our Flex Fund project, which is titled Autonomous Biomimetic Robofish for Offshore Wind Farm Inspection. We tersely like to refer to it as Robofish. Now, Robofish is aimed at addressing a critical need with offshore wind systems to be inspected regularly. Now, these inspections can be dangerous for divers, they're very costly, and we would like to be able to produce a system that is capable of doing loitering around offshore wind energy and other energy apparatus, and doing consistent inspections autonomously without a great deal of human input. Now, in order to build robots that can do this, they need to be very self-sufficient. My specialty is at the Space Robotics and Autonomous Systems Lab at the University of York in space robots, which tend to be very self-sufficient and have to take care of themselves under challenging conditions and harsh environments. The way we address this is through modular self-configuring and self-aware systems, which effectively means that rather than one big component that can fail, you have lots of little components working together trying to take care of each other. And we have systems, for example, that can self-configure using robot arm on the left up there. Our concept for Robofish is it's bio-inspired, very much like a cellular organism in form, and involves having several segments rather than having a single centralized architecture. We aim to have a multi-segmented architecture that allows us to distribute components and capabilities throughout the entire design. It's a flexible system. The key requirements that we're aiming at are maneuverability, power efficiency, as well as autonomy. In order to achieve these, we're taking cues from nature and we're using a flexible bio-inspired structure. One of my areas of research focuses on tensegrity structures, which are flexible, multi-degree of freedom robotic frames that operate very much like spines and joints in nature. And we, of course, will also need to be able to power this. So with the assistance of our partner, East Coast Oil and Gas, we will be able to dock the Robofish to a subsea power hub, which you see on the bottom right, in order to recharge. And to be able to complete its inspection capabilities. Inspection is mainly visual at the moment, but we're looking at also doing acoustic communications and acoustic localization as well as the ability to add other kinds of inspection payloads as might be needed for offshore renewable energy infrastructure, and for also communicating with other robot fish. You can send these in swarms to do group inspections, and then if you lose a few of them, perhaps here and there, it doesn't severely affect the operation of the wind farm. Now, designing the robot fish, of course, is a challenge. Any kind of bio-inspired structure needs to be modeled effectively as a natural sort of organism would. So our partners at University of Strathclyde, the Computational Fluid Dynamics and Fluid Structure Interaction Research Group, led by Dr. Ching Xiao, is performing fully coupled computational fluid dynamics simulations and is actually developing both the structural design for a biomimetic robot fish and also the control system that we will use for it. Obviously, we're not using a traditional kind of robotic control. This is a bio-inspired control system designed to emulate highly efficient movement behaviors to save energy, and also to be able to provide us with that maneuverability that we will need for inspection and docking tasks, which are very challenging in shifting currents and such. To do this, they have some very complex computational fluid dynamics code with which they've been able to model these kind of multi-body linked structures in their movement, and also to be able to generate some results for propulsion capability and maneuvering capability using, for example, a caudal fin, as you see on the right. So we also, of course, have the challenges, all the challenges associated with normal underwater robotics. We have a great deal of input from PIC-C Incorporated, and Andrew Durant is here in the audience. You speak to him about underwater robots if you like to. And The challenges, of course, are being able to ensure that this fish can be watertight, that it can perform its inspection operations reliably, and can also reach the depths that are needed for inspection. If we're talking about anchoring wind farm structures, we're looking at future designs, possibly not the prototype, but future designs going down potentially to 120 meters or so. So, a very challenging project. We also have the support of the Offshore Renewable Energy Catapult, and I look forward to working with everyone in the Offshore Renewable Energy Hub. And certainly come and find me if you have interest in robotics. And thank you very much. And thank you for the Hub as well.